Hi friends, in this session we study about the algebra of real functions. In algebra of functions we have to study about the operations of two functions like addition, subtraction, multiplication and division. What would be the domain of this sort of function? So if f and g are two real functions whose domains are d1 and d2 respectively. Also let d is equal to d1 intersection d2 be the common part of two domains and d1 intersection d2 should not equal to phi. So here I would like to explain all the addition, subtraction, multiplication and division. You see here the sum of f and g denoted by f plus g is defined as f plus g of x should equal to f of x plus g of x whose domain is d. D is d1 intersection d2. The d1 is the domain of f and the d2 is the domain of g. The difference of f and g denoted by f minus g is defined by f minus g of x is equal to f of x minus g of x whose domain is d. The product of f and g denoted by f dot g is denoted by f dot g of x is equal to f of x dot g of x whose domain is d. The quotient of f and g denoted by f over g is defined by f over g of x is equal to f of x over g of x whose domain is d minus x such that g of x is equal to 0 because the denominator should not equal to 0, so we are deducting this from that intersection d over d1 intersection d2 which is equal to d. The constant multiple of f and g denoted by cf, where c is a constant, then cf of x is equal to c multiplied by f of x whose domain is d. So now we take one example and we try to get more understanding about these sort of algebra of real functions. So we start with an example. First I write that we have a function f of x which is x square, and we have another function g of x which is 1 over root x minus 2. So here you see we know already that we have studied in our previous session that the domain of quadratic function is R. Domain for this function is R. It means domain is minus infinite to plus infinite. We have to write in the interval form, so it would be minus infinite to infinite. Now you see about a g of x. G of x is equal to 1 over root x minus 2. The denominator should not equal to 0, but here is a square root sign, so x minus 2 should greater than 0. If it is 0, then it would not define. So here we see the domain is x minus 2 is greater than 0. It means x is greater than 2. So I write here d2 we have you see greater than 2. So 2 to infinite we have d2, and d1 we have minus infinite to plus infinite. So we need d. D is equal to d1 intersection d2. So d1 intersection d2 is 2 to infinite. So it would be 2 to infinite. This is our d. So in this way we could find out the domain range. This domain range for all sort of the algebraic function for these two functions f plus g. If we have to take the domain would be like this. Everywhere the domain would be same. Okay. Now we have f of x is equal to square root of 9 minus x square, and g of x is equal to 1 by 2 sine x. We have this. Now we have to find out the common domain for this algebra of these functions. So we have to find the domain for f plus g of x, or the other algebra of these two functions, the f minus g of x, f into g of x, and f over g of x. So first we find out when the domain of all the functions would be same except for the constant function where d minus x such that g of x is equal to 0. So here we see we have to find out. So first we find out the domain for f of x. So domain of f of x, d1 we have to find out. So d1 is equal to, d1 should be, right, in this way. For d1 we see that 9 minus x square, so greater than equal to 0. It should be greater than equal to 0 because it is in the square root sign, though no negative number should be there. So minus, we will get here, if we simplify this, so x square minus 9, just a moment, is smaller than equal to 0. So we get here x plus 3 and x minus 3 is smaller than equal to 0. So we get here, now we have got this, now we solve this. So here we get minus 3 is smaller than equal to x is smaller than equal to 3. So this is our domain. We have got d1, which is, or we could write in another way also. It is like this, or we could write in a interval form, minus 3 to 3, both are included here. So we write in this way. Okay, now we have to find out the d2. Now for d2 we see, for d2, for if g of x is equal to 1 by 2 sine x, we know that domain of sine x is r. So here is r, so we could write in this way, minus infinite to plus infinite it would be. So but the d, if we have to find out the d, so d is equal to d1 intersection d2. So here you see, and here also, so the intersection would be minus 3 to 3. So minus 3 to 3 is the d for us for both the combined function, minus 3, 3. So this would be the domain for this sort of function. You know that the domain for this f plus g of x, f minus g of x, and f into g of x is d. Domain we know that for this sort of function d, which is equal to d1 intersection d2. But for f over g of x, the domain is d minus x such that g of x is equal to 0. So first of all, we see here we have a function. If we see that f of x over g of x, f over g of x is equal to f of x over g of x, or we have the f of x is 9 minus x square and g of x is 1 over 2 sine x. So as per this definition for getting this domain for a cosine function, we get here g of x is not equal to g of x is equal to 0. I have to put here, so half sine x 1 over 2 sine x is equal to 0. Sine x is equal to 0 because you know that the value of sine 0 is equal to 0, so x is equal to 0 here. And somewhere also we see that x is equal to 0 is equal to 0, x is equal to pi is also equal to 0, then x is equal to 2 pi is also 0. So in this way we see that this is our domain. So the value of pi, we know that it is 22 over 7, which is 3.14, which is more than 3, and the value of pi is 22 over 7, which is 3.14, but we know that the d, which is minus 3 to 3 in closed interval, so it is more than pi is more than 3, it is 3.14, so it won't be in our d, so we have to just subtract 0 from d. So the domain of f over g of x is equal to d minus 0. So here we know that d is minus 3 to 3 and this one is 0, so we could write in other way also. So domain is minus 3 to 0. In this way 0 is not included, union 0 to 3. So this would be the domain for this f over g of x function. Thank you.